This is my original function, and this is my derivative. One way you can quickly tell is this is a cubic, and when you take a derivative, it always drops the power, so this is your squared. All right, so I'm going to ignore my original function because I want to focus on the derivative. All right, because some questions I want to talk about here are when is the slope of this function 0? Well, if you look at it, the slope is 0 right there, and the slope is 0 right there. Okay, because that's the hill and the valley. And if you go up, do you see where the x-axis actually hits nicely at those points? Oh, so those are at this point and this point. Now, it looks like that's -2 and 0. We're going to use the calculator to get exact values of those and see for sure if that is the case. All right, so we're going to talk about when the slope is 0. We're also going to ask questions of when's the slope of this, say, 3? When's the slope 3? So when is the slope of this graph +3? It's somewhere here. There'll be a slope at 3, and we'll talk about how to do that. And we're also going to talk about what would the second derivative of the graph look like at a specific point. So there's a couple questions we're going to ask. So the first question is when is the derivative, the slope of this 0, and then when is the slope of this 3? So I'm going to get rid of this graph for now because it gets a little confusing with too many graphs, but realize again, we're looking for when the slope of this is 0, which is right here and here, and when it's 3, which is somewhere in here, because here it's going down and here it's going down, so somewhere in here will be a slope of 3. We'll talk about that. But first, let's get rid of that graph. So I'm going to hit tab right here, go up, and I'm getting rid of the original function. So all I have is the derivative now. All right, so when is the slope? This is a slope function equal to 0. So we want to find the zeros right there. So to do that, we're going to hit menu, and then we're going to do analyze graph, and we're going to do menu analyze graph in zeros. So I want to do, oops, that shouldn't have moved. Okay, I want to get this side right here. So I want from here to here. And my 0 is right there, so I got to kind of surround that. So I got -2, 0 is one of my zeros. So -2 was accurate. Now that does look like 0, so let's verify that. If I click on this, I got graph, analyze graph, and I'm going to do zeros. And oops, man, it keeps doing that. Okay. And then right here we want this 0, so I want to start to the left of it, scroll across to the right of it, and there it is, 0, 0. So my two zeros are -2 and 0, is where the slope of the blue graph originally was 0. And that's what we thought we had. So zeros helps you find where the slope is 0. Now my question was, where is the slope equal to 3? Well, let's talk about that. It looks like, well, this is a slope graph, so isn't the slope equal to 3 right there? Well, let's see. Where is the slope equal to 3? Let's check this out. So I want the slope equaling 3, so I'm going to put a graph of 3. So graph of 3, and what happens is there's the graph of 3. So if I want to know where the derivative equals 3, isn't that where the two lines intersect? So where does the black line and the red line intersect? It looks like right there at the tip. So how do we find that tip where they intersect, where the derivative equals to 3? Well, we go back to menu, we go to analyze graph, and this time we're going to do intersect. I only have one intersection, so I just go left of where the intersection is, span across to the right of the intersection, and it looks like my value is at -1. So -1 is where the derivative is 3. And when is the derivative 0? No, sorry, not when the derivative is 3. Yeah, when the derivative is 3. And when is the derivative 0? At -2 and 0. So the slope of the original graph, if we go back to the original graph, let's put it on real quick. Put it back on. We're going to open it, put it back on right there. Boom. So look at this. The original graph had a slope of 0 here and here. Right here looks like my slope is 3, so they're saying that slope right there, at that point right there, is 3. All right, and that's what we found out. Now, let's go back and say, okay, what would the slope be, say, at 1? So what if I said, I want the slope at 1? So if I go down here, how steep is it right there at 1? Well, you can tell it's negative something. But how do I find the slope at that point? Well, so I want the slope of the blue graph. Well, I could just look two different ways. I could look at this equation, or I can find the derivative of this equation. So because isn't the red just the derivative? So if I want the slope of the blue graph at 1, let's do this. If I do Control T, I get a table. Now if we look at that, at 1, this right here is the function value, but if we go over a second, this right here is the slope. So at 1, the slope is -9 of your blue graph. At 2, the value is -18, but the slope is -24. If we go back up to this, watch this. Remember the -1? At -1, the value was 0, but the slope was 3. And that verified, we talked earlier, that our slope is looking for 3. Kind of nice. So this right here is a table of slopes. Now let's say I didn't want to use the table. Let's say I just want to look at the blue graph and find out where the slope is, what the slope is, say at 1. So let's go back. We know it's going to be -9, but let's verify that. Let's get rid of the table. Control T. All right, now I want to focus on what's the slope of this graph. So what I'm going to do at 1, I'm going to hit Menu, Analyze Graph, and I want to find dy dx, which is the slope. So I want to find the slope. Now it doesn't say where. Oh, sorry, when I choose a graph, I want this graph. So I'm going to choose that graph. And where do I want it? Well, I could move my little pencil up and down, but what I'm going to do is I'm simply going to type 1. Enter. And at 1, right there's the dot, -9 is your slope. See that -9 right there? I can find the slope anywhere on the blue graph. Okay, let's say you wanted the slope at a second derivative. Well, that means I want the slope of this red graph somewhere. So if I wanted the slope of this red graph, say at -3 or something, I could do that just of the red graph. You can always use the derivative function to find slope anywhere. So we found zeros of the derivative. We found when the derivative is 3, and we found what is the derivative at 1. Different ways to do different things. Hopefully this helps. Good luck.